If the electric charges do not flow, there will be no electricity. But what causes these electric charges to flow?
Let us look at this tube connected with a water tank. If you keep the mouth of the tube at the same level as that of the level of water in the tank, there is no flow of water. The reason is that, as both the ends are at the same height, there is no pressure difference. However, if you bring the level of the tube down, water starts flowing out. Now as one end is at a height, so the pressure difference is created at that end. Because of the gravity, the height of the water at the higher end creates much more pressure and the water flows.
Could we relate this to the flow of charges too? Is gravity also responsible for the flow of charges? Certainly not. So what causes the electrons to flow? Like in the case of water, there must be some driving force. Well, in this case, it's the electrical pressure. Yes, the electrical pressure difference. Or more appropriately, for charge to flow, there must be a difference in the potentials at the two ends of the conductor. This difference in the potentials is produced with the help of a battery, consisting of one or more electric cells.
So when the cell is connected to the conducting circuit element, there is a potential difference between the two ends of it, which sets the charge in motion in the conductor and produces electric current.
We already know that energy can neither be created nor destroyed. It can only be converted from one form into another. All the appliances that we use in our daily lives are a perfect example of that. Now, even a cell or a battery is an appliance which converts energy. It converts chemical energy into electrical energy. Ever wondered why we use different batteries in different appliances? Why the batteries used in a remote are pencil thin and those in a torch are slightly fatter, and batteries used in inverters are even bigger? That's because bigger batteries mean more potential, more energy, and hence more power. Which means that this fat battery has more power than this slick size 01. But the question is, by how much? Well, we distinguish batteries by their potentials, and their potential is measured in volts.
In an electrical circuit carrying current, the potential difference between any 2 points is defined as the work done in moving a unit charge from one point to other. So, the potential difference between A and B would be the work done to move unit charge, that is, 1 coulomb of charge from A to B. The SI unit of potential difference is volt, named after an Italian physicist, Alessandro Volta. The potential difference between 2 points equals to the work done per unit charge.
The power that comes in our home supplies is 220 volts. I was wondering, how much would 1 volt be worth?
One volt is the potential difference between 2 points when 1 joule of work is done in moving a charge of 1 coulomb from one point to the other.
We already know that the potential difference between the 2 points is the work done in moving a unit charge from one point to the other. Well, I guess now you have a better idea of what it means when it says 1.5 volts.